So this is the first lesson in Unit 11-12, and Unit 11-12 is all about finding connections between relationships. And in 11a, the first thing that you're asked to do is work with distance time graphs. So what I want to do in this lesson here is go through what a distance time graph looks like, how you can interpret distance time graphs in terms of distance, time, direction, and speed. And by the end, you want to be able to match a description of a situation to a distance time graph that represents it. Or, if you're given a distance time graph, write out a little story that represents what's going on. So you should have a page up at the top. It just says, in this unit we'll be using the CBR, which is this thing here, to investigate distance time graphs. Now let's just look at a few examples here of what distance time graphs would be produced. So example 1, a student starts close to the detector and moves away from it at a constant speed. So if this is the detector right here, I'm starting sort of right here, right up close to it, and I'm moving away from it gradually. Okay? Now what the detector is measuring is it's measuring at each second or each millisecond, it's measuring how far away I am from the detector. Okay? And we want to represent that information in this graph. So if I start close to the detector is sort of right down here at the bottom. So I'm just going to put CBR right here. Okay? And what we have on the vertical axis is the distance between me and the CBR. So if I start, as it says here, close to the detector, am I a long way away from the CBR or close to the CBR? Obviously, Drake. Yeah, I'm right in front of it. So I'm going to start someplace really, really close like this. Okay? So this is my start right here. Now, as time goes on, the line representing how far away, is it going to go up or is it going to go down? Is the distance going to increase or is it going to decrease if I go like this? It's going to go up. So what we want is we want to draw a straight line that goes up like this. Okay? Because the distance between me and the detector, which is this distance in here, I'll just say distance is increasing. Okay? So let's look at the next example. Okay? A student starts away from the detector and moves towards it at a constant speed. And all of this stuff, constant speed, this just means that your line is going to be straight. You're going to have a straight line when you draw it. Okay? So constant speed just means straight line. So what is this graph going to look like? Well, if I start far away from the detector, I've got to start way up here. Okay? The distance between me and the detector has to be big at the beginning. And if I move towards it, is my line going to go up or is it going to go down? It's going to go down, right? So let's just draw our line in here. I'll try to do this in red again. Yeah. I'm going to get closer as I go on. Okay, because my distance between me and the detector is decreasing. So I'll just say distance decreases, or it gets smaller. Okay. So whether this line goes up or down tells you what direction the person is moving in. If the line slopes up, that means the person is moving away from the CBR. And if the line slopes down, what does that tell us? How are they moving relative to the CBR? Are they getting closer to it or further away? If the line is yeah, they're getting closer. So they're moving towards it then. Okay. So those are the two things you want to keep in mind. Moving towards it, line goes up, line goes down. Moving away from it, the line slopes up. Okay, so let's take a look at examples 3 and 4 here. A student moves away from the detector slowly and then speeds up. So what's going to happen here is, I'll just draw these lines in here for you. At first, they're going to start close to the detector, and then they're going to start moving sort of slowly like this. Okay? The distance between them and the detector, okay, is getting larger, but it's not getting larger very fast, so this line isn't sloping up very much. If they speed up, well, what's the line going to look like? Is it going to go steeper, or is it going to go less steep? What do we think? Steeper or less steep? Steeper. You're right. It's going to be steeper if they speed up. So I would have to do something like that right there. And I'll move this guy down a little bit so it matches up. Okay? So he starts off going slowly, and then he goes steeper. Okay? So the steepness of the line, or the slope of the line, tells you how fast they're going. A steep line means that they're moving fast. And a less steep line means they're moving slow. Now, let's look at example 4 here. A student stands 3 meters in front of the detector and does not move. So let's say this is me. There's the detector. I'm standing 3 meters away, and I just stay here. What is that line going to look like? How is the distance between me and the detector changing? Exactly. It's not going to change at all. It's just going to go straight across. So if we go to 3 meters here, let's say 1, 2, 3, our line is just basically going to go straight across. 2, 3, and oh, there we go. That's what my line is going to look like. Okay. Okay, because I'm not moving. My distance isn't changing. So what does a horizontal line mean? If you see a horizontal line on a distance time graph, what does that tell you about that thing that's moving? It's staying still, yeah. It means standing still. Okay? So Drake, you want to draw in a line, 3 meters standing still. Okay, horizontal line. Okay. Okay, so here we're given a graph, and we want to talk about how a student is going to have to move in order to make this graph. And the easiest thing to do is look at 3 things. In this case we're going to look at 4 things. 5 things, I guess. First, we look at where they start. Okay? And then we look at each little section of the graph. 1, 2, 3, and 4. Okay? And we want to think about what each of these things tells us about the person moving. Okay? So look at the starting point. Are they starting close to the detector or far away from it? What do we think? Close or far? Close. Yeah, so we'll say they start close to the detector. Close. CVR. Now, what are they doing in section 1? Are they moving towards it or are they moving away?
Moving towards it. Away.
Away, yeah. The distance is increasing, so they move away. So let's see. They move away. Now, do you think they're moving slowly or quickly? They're fairly slowly. Move away somewhat slowly, let's say. Okay, and that's section number 1. Okay? So I'll just put in brackets here section number 1. Okay? Now, in section 2, are they moving towards it or away from it? What do you think, Drake? Towards it or away from it? Section 2. They're still moving away. Now, are they going faster or slower? Yeah. So in section 2, we can say, and they keep moving away. But slower. So that would be section 2. Okay. What are they doing in section 3, Riley? Okay, so we can say then they stop. And what about that last section, section 4? Are they moving away or towards?
They're moving towards it.
Yeah. So then they move towards. Now, do you think they're going towards it quickly or slowly? What do we think? Is this line steep or not very steep compared to the lines that we have in 1 or 2? Kurt? Yeah. Move towards it. I'll say towards the CBR quickly. Yeah, because it's a fairly steep line. Okay? And we're done, okay? So you want to divide this thing into little sections and then talk about what's going on in each one of these sections. Okay? Okay, last question here. Here, we've got to do the opposite. We have got a situation and we want to draw the distance time graph. A student starts 3 meters away from the CBR, walks slowly towards it. When they are 1 meter away from it, they stop and wait for 2 seconds. Then they walk quickly away from the detector. We want to draw the distance time graph. So the first thing I'm going to do is I'm going to put some numbers on here. 1, 2, 3, 4. And we'll say that each one of these along the bottom is 1 second. Okay. Where should they start? Start is always going to be right on this distance axis. So they need to start 3 meters away from the CBR. So they're going to start right here. Now they want to walk slowly towards it. So I have to draw a line. What kind of line do I want to draw here if they're walking slowly towards it?
Steep.
Not very steep. We want the opposite. We want a very shallow line if they're moving slowly. So slowly, we want a very, sort of a not very steep line here. So let me draw something that is not very steep. We'll just kind of go like this. Okay? We'll say that that's them walking towards it. They're not going very fast, but they're moving towards it. Next thing they do is they want to stop for 2 seconds. So what do I need if they're going to stop? Logan, what kind of line do I need if they're stopped? And should it go up, down, straight across? What? Yeah. And it says they stop for 2 seconds, so this should go for about 2 seconds there like that. Okay? So straight across like that. Then they walk quickly away from it. So if they're walking away from it, should the line go up or down? What do you think, Drake? Up or down? If they're walking away. If they're going away? Yeah, it's got to go up. And if they're going quickly, should it be very steep or should it be very shallow? What do you think?
Very steep.
Very steep. So let's have them walk quickly away. This will go right up here like this. And we're done. That's our distance time graph.